Now we're on lesson 52. We're looking at word problems, and a lot of times you're given the equation, so you just have to answer questions about the scenario. So for exercise number 1, it says the 4th of July fireworks shown in Sargadees can be modeled by the graph to the right, which has the equation y equals negative 3.8 t squared plus 48t plus 1.1. And part A says if the rocket will explode at its highest point, approximately what time t will the rocket explode? And then part B says at approximately what height will the rocket explode? So if we're looking at the highest point, we're looking right here. And this is the point, I'm going to say 150. So x is always time, which means the y is the other variable. So now let's look at these questions again. It says if the rocket will explode at the highest point at approximately what time? So we have 6 and 6 seconds. So at about 6 seconds, and what height in feet? So now we know the y stands for height. So at about 150 feet. Okay, and that's all there is to this portion. So now let's look at exercise 2. We have a little more work to do because they didn't do the graph for us. The height of an object that is traveling through the air can be well modeled by a quadratic function that opens downward. An object is fired upward and its height in feet above the ground is given by, remember, h of t can also be used as a y equals negative 16t squared plus 64t plus 180. T is the time in seconds the object has been in the air. Now, part A says, using your calculator, sketch a graph of the object's height for all times where it is at or above the ground. So if it's at the ground, y is going to be 0. So what you should do first is go to y equals and type that in. So I have a screenshot here. Notice that I don't use t's. I'm still using x's, okay? If you put t squared, you're going to freak it out. So I just recopied my equation, but I put x's instead of t's. From there now, I go to my table, okay? I press second graph, and your calculator will go on forever because it doesn't realize we're doing a word problem. Remember, when something hits the ground, that height is 0 because it's touching the ground. So you are going to, and also time is 0. So when you do these problems, you start when x is 0 and end when the y is 0. So on this table, what this is saying, when the time is 0, we're starting 80 feet in the air. And when we hit the ground, this would be 5 seconds. So now we're going to copy that down off to the side. So I'm going to do x and y, start at 0 and end at 0. 1, 2, 3, 4, 5. And then 80, 128, 144, 128, 80, 0. And now we are going to plot these points. So 0, 80 is right here. 1, so here's 120, 128 is about here. 2, 144. 3, 128. 4, 80, and 5 seconds, y is 0. So our shot looks something like that. So we did part A. Now it wants to know for part B, what is the maximum height That's not time. That's asking what the y value is. You can look on your table at 144, or you can look on your graph right here. So I'm going to say 144 feet. And part C, at what time does this thing hit the ground? That's where the y is 0. Right there. 5 seconds. And then part D, over what time interval is the height increasing? That means, where is it going up? So right when we have time 0 to time 2. So we're going to use that interval notation we did back in the fall, 0 to 2, and then I'm going to put my square brackets. So between 0 and 2 seconds, that whatever we shot out, an object is increasing. Now let's go to page 3. Same idea, just a little bit different of a scenario. So a pistol is accidentally discharged vertically upward from a height of 4 feet above the ground. So somebody's holding it in their hand. Its path is given by this equation. H is the height and T is the time in seconds. We're not going to draw a sketch. We're just going to take a look at the table. So what I'm going to do first is type our equation into my y equals. All right, so there it is. Remember, you don't use a T when you use the y equals. You replace that T with an X. And you can hit graph, but you're not going to see a very good looking graph. I'm just going to go right to my table. And remember, in these word problems, we start where the X is 0 because that's our starting time. And then we end where the Y is 0. Actually, I have it on another screenshot, but I couldn't quite get it all in one screen. So in this case, the Y is never 0 on our table, but at 11 seconds, it says negative 172. So we know nothing's going to go 172 feet in the ground. So this is the table that I'm using. This is the table that I'm going to copy onto my paper. You do the same thing. I'm going to pause my video and copy this. Okay, well, that was slightly painful, but I got my table copied. And now I'm going to answer some questions. After how many seconds will the bullet start coming back down? So remember, our bullet, it goes up and then it goes down. So coming back down is like this section right here. So we're going to look and see where our height starts to decrease. 4, 148, 260, 340, 388, 404, then look, back down. So after 5 seconds, that's when it reaches its highest point. So after 5 seconds, the bullet will start coming down. And what's the highest height? Well, it's 404. That's pretty high. And part D, to the nearest whole number, about how many seconds will it take for the bullet to hit the ground? So at 10 seconds, it's 4 feet above the ground, basically. So we're going to say 10 seconds. At 11 seconds, according to our model, it's negative 172 feet in the ground.